Hey there, hope you're doing good. In college, you must have learnt about NP complete problems and NP hard ones and time complexity, which can be polynomial, exponential, factorial, or something else. All this may be intimidating. You may even wonder whether this is practically necessary because you're not a computer scientist, you're here to get practical work done. Is this necessary for you? A part of it is, and I'll explain that part in an easy to understand form. The reason we learn all this is we need to avoid inefficient algorithms. I'll call them that instead of using terms like NP complete or exponential or whatever. Inefficient algorithms have the property that as the input size n increases, the time the algorithm takes to run increases extremely fast. So a little increase in n can cause a huge increase in the runtime to years. So what will happen if you don't understand this concept? Your code will hang. And if it's on the server, it'll hang for all users. Further, hackers can take advantage of this vulnerability by sending requests that trigger this behavior. And even a small amount of input data is enough to cause this problem. Because that's what makes these algorithms inefficient. An efficient algorithm takes more time given bigger input, but not disproportionately so. Inefficient algorithms can balloon like anything. So that's why you need to understand this concept so that you avoid writing them. And how do you identify whether you're writing an efficient or an inefficient algorithm? In an efficient algorithm, you take the first step in solving the problem. And then you solve the remaining problem. And this is the key part, you don't have to come back and revisit your first step and change it. Let me give you an example, sorting an array. To sort an array, let's say we identify the smallest element in the array and swap it with the first element. Now you have an array of size n minus 1. So you sort the rest of the array by running the same algorithm repetitively. The key insight is, once you identify the smallest element and put it in the first position, later steps will not invalidate this decision. You won't realize later on that, oh no, actually something else should be in the first position. And you won't have to undo your work. Because if you keep undoing work you already did, it will take a lot of time. So that is the key insight here. Let me give you a counter example. The traveling salesman problem. In this problem, you have a salesman who needs to visit a number of cities, say Bangalore, Delhi, Chennai, Vizag, etc. And there is a journey time which varies depending on the city. From Bangalore, it's faster to get to Chennai than to Delhi. Now the question is, what order should the salesman visit all these cities to minimize the travel time? This is an inefficient algorithm. Technically speaking, NP complete, but we won't go there. It's an inefficient algorithm. Why is it inefficient? Because you can't definitively take a first step. You can't say the first step is to go to Chennai. It depends on the subsequent steps. So you take a step, then you proceed with the execution of the algorithm, then you may have to revisit the first step. This is very wasteful. That's what makes it inefficient. So you end up listing out all the combinations and testing each of them to see how much time it takes. So that is another sign you can look out for. So keep these two signs in mind when writing algorithms. One, are you able to take the first step, which will not need to be undone later on? Second, do you have to enumerate all the possibilities and test them.